The second question is, show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some integer. This is the question. Please note down this question because I need space to write the question answer. So I am going to erase the question. So please note down the question by stopping the video. Okay. Show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some integer. Okay, this is the question. Here, to solve this problem, we have to use Euclid's division lemma. Answer: let A be any positive integer and b equal to 6. Let A be any positive integer and b equal to 6. We know that when A is divided by b, we get the quotient q and the remainder r, and the relation is A equal to b into q plus r. So here in this case, when A is divided by b equal to 6, when you divide A by 6, quotient is q, remainder is r. Quotient is q and the remainder is r. But here the remainder can be 0 or 1, 2, 3, 4, 5. Because always we divide in such a way that remainder should be less than the divisor. So remainder can be 0, 1, 2, 3, 4, 5. Okay. Using Euclid's division lemma, we can write A equal to b is 6 into divisor into quotient 6q plus remainder r for some integer q greater than 0 and r is less than 6, greater than or equal to 0. That is, r can be 0, 1, 2, 3, 4 and 5. So here when r is 0, A becomes 6q plus 0. When remainder r equal to 1, so here A becomes 6q plus 1. When remainder is 2, 6q plus 2. When remainder is 3, 6q plus 3. When remainder is 4, 6q plus 4. When remainder is 5, so A equal to 6q plus 5. So possible values for A are A equal to 6q when remainder is 0, or A equal to 6q if remainder is 1, 6q plus 1. A equal to 6q plus if remainder is 2, 6q plus 2. A equal to 6q plus if remainder is 3, 6q plus 3. Or when remainder is 4, 6q plus 4. Okay, here r should come, r. Here also r. Or I will write again. Otherwise, the next. A equal to 6q or 6q plus 1, or A equal to 6q plus 2, or a equal to 6 cube plus 3 or a equal to a equal to 6 cube plus 4 or a equal to 6 cube plus 5. So as I have told already, if remainder is 0, a equal to 6. If remainder is 1, a equal to 6u plus 7. And remainder is 2, 6u plus 2, 3 and so on. Here a equal to 6 cube, a equal to 6 cube or a equal to 6 cube plus 2 or a equal to 6 cube plus 4. These are all divisible by 2. Here let a be any positive odd. We have to write here odd because they have told. Let a be any positive odd integer and b equal to 6. So a equal to 6 cube, a equal to 6 cube plus 2, a equal to 6 cube plus 4. These are all divisible by 2. Here 6 cube means remainder is 0. If remainder is 0, that is divisible by 2. Means 6 cube is divisible by 2. 6 is divisible by 2. Here 6 cube plus 2 is also divisible by 2. See here, if you take 2 common, it becomes 3 cube plus 1 divisible by 2. Here 6 cube, you take 2 common, 3 cube plus 2. This is also divisible by 2. All these are divisible by 2. If these are divisible by 2, these are not odd integers. These are divisible by 2. Therefore, these cannot be positive odd integers. These cannot be positive odd integers. Which are the remaining? Therefore, a equal to 6 cube plus 1, a equal to 6 cube plus 3, a equal to 6 cube plus 5. These are not divisible by 2 because 6 is divisible by 2 but 1 is not divisible by 2. Here 6 is divisible by 2 but 3 is not divisible by 2. That is, you cannot take common and cancel. Here also 5 is not divisible by 2. Remainder is 5. So these are all not divisible by 2. Are not divisible by 2. Therefore, here you can say, therefore these are positive odd integers. These are positive odd integers. That is, any positive odd integer is of the form. Therefore, last statement is, therefore any positive odd integer is of the form 6 cube plus 1, 6 cube plus 6 cube plus 5. Okay. Or I think you understood this answer. Okay, we shall go to next question. I'll write the next question. Now we shall see exercise 1.1 question number 5. Question number 5 is use Euclid's division lemma to show that the cube of any positive integer is of the form 9m plus 1 or 9m plus 8. This is the question. Please write the question. Now answer. Okay. Let A be any positive integer. Let A be any positive integer. Let A be any positive integer and B equal to 3. Already we know Euclid's division lemma. If an integer A is divided by B, quotient becomes Q, remainder becomes R. So we can write A equal to B into Q plus R. Here in this case, integer A is divided by B equal to 3. So Q is the quotient, remainder is R. Therefore, you can write A equal to 3 into Q, 3 into Q plus R. But remainder can be 0, 1, 2. These are the possible remainders because divisor is 3. Remainder will be always less than the divisor. So we can write using Euclid's division lemma. We can write A equal to what? 3Q plus R, where Q is some integer. For some integer Q greater than 0, that is quotient is greater than 0, and remainder are equal to, possible values of remainder are 0, 1 or 2. When remainder R is 0, so A becomes 3Q. A becomes 3Q. Okay. And here our question is, we have to find cube of any positive integer. So I will find the cube of this. A cube is 3Q bracket cube equal to 27 Q cube. That is equal to, what is told to prove? So it is of the form 9m plus 1 or 9m plus 2. So I can write this as 9 into bracket 3 Q cube. So this is equal to 9. Q is an integer. Q cube is also integer. 3Q cube is also integer. So I'll write here m, 9m. What is m? Where m is an integer. Where m is an integer. When Next is when remainder is 1. If remainder is 1, A becomes equal to 3q plus r is 1. If I cube this, if I take cube of this, so it becomes 3q plus 1 bracket cube. So here aq plus bq plus 3ab into bracket a plus b is our form. So 3 cube bracket cube plus 1 cube plus 3 cube into 1 into 3 cube plus 1. This, if we simplify, this becomes 27 cube plus 1 cube is 1, 3 3s are 9, 9 3s are 27. So 27, 3 3s are 9, 9 3s are 27, q into q square plus 3 3s are 9, q 9q into 1, 9q. I'll rearrange the terms. So I'll rearrange the terms. I'll write on that side. 27 q cube plus 27 q plus 9q plus this is 1. All together, this is, from this I can take 9 common from this. I'll take 9 outside. What is remaining? 9 3s are 27. So 3q plus 9 3s are 27 cube plus 9 is taken outside, 1 is remaining, plus 1. Okay. Here 3q plus 3q plus 1. This all together one integer. 1 is integer, q is also integer, 3q is integer, all these are integers. Sum of these integers is again an integer. So I can write this as 9. For this I'll write 9m plus 1, where m is an integer. Where m is an integer. So if a equal to 3q plus 1, we get 9m plus 1, where m is an integer, where m is an integer. So last one more case, when r equal to 2. Now when r equal to 2, and remainder is 2. When remainder r equal to 2, a is equal to 3q plus r is 2. So a cube is nothing but 3q plus 2 bracket cube. This is equal to first term cube, 3q bracket cube, second term cube plus 3a first term 3 cube, second term 2 into bracket first term plus second term. So this is 27 cube plus 2 2s are 4, 4 2s are 8, 2 cube is 8, 3 3s are 9, 9 2s are 18, 3 3s are 9, 9 2s are 18, 18 is 54, 54 q into q square plus 3 3s are 9, 9 2s are 18, 18 2s are 36, 36 q. Now I'll rearrange these terms. So 27 q plus 54 q square plus 36 q plus 8, I'll write 7 plus 1 I'll write, or I'll write 8 as 7 plus 1. Answer is not necessary. 7 plus 1, 8. So this is equal to, this all together becomes one integer. Before that we can take 9 common. I'll take 9 outside. 9 3s are 27. 3 cube plus 9 6 are q square plus 9 4s are 4 cube plus 8. So this is equal to, here 3 cube plus 6 q square 4 cube, all together this is one integer. Okay, so I'll write 9 m is 3 cube plus 6 q square plus 4 cube plus 8, where m is an integer. Okay, therefore square of any cube of any positive integer, therefore cube of any positive integer is of the form, what is that? So 9m plus 1 or 9m plus 8. This is the answer. Okay, we shall continue in the next class. Now we shall go to fourth main. I'll read a question for you. Use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. They have given the hint. Hint is, let x be any positive integer, then it is of the form 3q plus 1, 3q plus 2. Now square each of these and show that they can be written in the form 3m or 3m plus 1. Now write the question. When you write the question, then only you will understand the answer. That's why you stop the video, write the question. I'm going to erase this. Okay. Now we shall go to answer. Here they have given the hint. Hint is, let x be any positive integer. I'll take x as any positive integer. Answer, let x be any positive integer and b equal to 3. We know when an integer a is divided by b, we get the quotient q and the remainder r. Then we can write a equal to b into q plus r. This is Euclid's division lemma. Here in our case, x is positive integer, and if this is divided by b is 3. 3 into quotient q and remainder r. Then we can write x equal to 3 into q plus r. So let x be any positive integer and b equal to 3. Then using Euclid's division lemma. Euclid's division lemma. We can write x equal to 3q plus r. For some integer q greater than 0, q is greater than 0, and r equal to 0, 1 or 2, because you are dividing x by 3, 3 into q, remainder is r, your divisor is 3, so remainder can be 0 or 1 or 2, not more than 2. So possible values for remainder are 0, 1 or 2. So when r is 0, x becomes 3q, or when r is 1, x becomes 3q plus 1. When r is 2, x becomes x equal to 3q plus 2. These are the possible values for x. But x is any positive integer. The question is, square of any positive integer is of the form 3m or 3m plus 1. Here it is positive integer, x is a positive integer. Square of any positive integer. Therefore, we have to square this. So, x square means 3q square. 3q square. This is nothing but it is 9q square. It can be written as, I will write this as 3 into 3q square. Q is a some integer greater than 0. Q is integer means q square is also integer. 3q square is also integer. So for this I will write m. For some integer m. For some integer m, or where m is integer. Yeah. Okay. When you take x square, it becomes 3m. Now we shall square this. X square is equal to 3q plus 1 bracket square. 3q plus 1 bracket square. So we shall expand this. First term square 9q square. Product of these two and double. So 3 ones are 3. Double 6q. 1 square is 1. Now I will take 3 common from this. If I take 3 common, it becomes 3q square plus 3 2s are 6q plus 1. Here again q is integer, 2q is also integer, q square is integer, 3q square is also integer, sum of these two is again one integer. So for that I will write m. So 3m plus 1. Again where m is what? Integer. For some integer m. For some integer m. Okay. Now x can be 3q plus 2. When remainder is 2, it is 3q plus 2. So again squaring this x. So x square equal to 3q plus 2 bracket square. If I square this, 9q square plus 3 2s are 6, 12q plus 2 2s are 4. Now I will rearrange these terms. 9q square plus 12q plus 3 plus 1. So space is not there, I am going to erase this part. So here I'll take 3 common. If I take 3 common, 3q squared plus 3 4 plus 12. So 4q plus 1 plus 1. This is equal to 3. Again 3q square plus 4q plus 1. All together this is also an integer. So for that integer I will take m, 3m plus 1. So this is 1. Where m is integer for some integer m. Okay, now we have seen square of this got 3m, square of this is 3m plus 1, square of this is 3m plus 1. So in all possible cases it is 3m or 3m plus 1. Therefore square of any positive integer is of the form 3m or 3m plus 1. The last statement is, we have tried last statement. Therefore square of any positive integer is of the form 3m or 3m plus 1. Okay, this completes question number 4. Next we shall go to next question. Good morning students. In continuation of last class, we shall go to the third main problem of exercise 1.1. I'll read question for you. An army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? This is the question. So I am going to erase this question and write the answer. Please stop the video and write the question in your notebook. Then we shall go to answer. Now I am going to erase this. At this moment you can stop it and write the question. Okay. Now you have written the question. I will go to answer. Before going to this question, just I will remind you, every year in the march past, you are going to stand in the line like this. 1, 2, 3 students. Next 1, 2, 3, 1, 2, 3, 1, 2, 3, like this. These are the columns. 1, 2, 3 columns. These are the rows. 1, 2, 1, 2, 3, 4, 5, like this. Here our question is members of army contingent is 616. Members of army band, so these are 32. So members of army band should stand in the front row, say like this way they should stand. Then members of army contingent, they should stand next to them. But question here is, in maximum, in how many columns they can stand? If they stand in only one column, members of army band 32 are there. So 1, 2, 3, so on. So 32 members will stand in one column. Next, 1, 2, 3, so on. So 616 members of army contingent will stand in 616 rows if there is only one column. If there are two columns, 1, 2, 1, 2, 1, 2, like this, 32 members are there, means here, so columns are 2, 1, 2 columns, rows will be 16 rows, like this, 16 rows, 1, 2, 3 and so on, 16 rows. And here members of army contingent, if they stand in two columns, 1, 2, 1, 2, like this, they need to stand in 616 by 2 equal to 2 3 is 0, 8, 308 rows. If there are two columns, members of army band stand in 16 rows, members of army contingent, they will stand in 308 rows. Whether they can stand in 3 columns? No, because 32 is not divisible by 3. We don't get here one whole number. So they cannot stand in 3 columns. If they stand in 4 columns, say army band 1, 2, 3, 4. 1, 2, 3, 4. Like this. 4 8s are 32. So they will stand in 4 columns, but rows 1, 2, 3 like this. 4 8s are 32. So in 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7. So I'll write one more here. 8. So 8 4s are 32. 8 4s are 32. The army band, members of army band will stand in 1, 2, 3, 4, 5, 6, 7, 8 rows if they are asked to stand in 4 columns. And remaining members of army contingent, 616 divided by 4 you do. 4 1s are 4, 2, 1, 4 5s are 20, 1, 6, 4 4s are 16. So they will stand in how many? Like this. If we ask them to stand in 4 columns, they need to stand in 154 rows. 154 rows. Okay. If we ask them to stand in 4 columns. Okay. Now, is it possible to stand in 5 columns? Not possible, because 32 divided by 5 you do. 5 6 are 30. If you ask them to stand in 5 columns, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5, 6 are 30 and 2 will remain here. Here 2 will remain. Means it is not divisible. 32 is not divisible by 5. So 2 will remain. Here they should stand in exact number of columns and the number of numbers in a row. This row should be complete. That is the question. So then it is divisible by what? Next number. Next number, it is not divisible by 5. It is not divisible by 6. Not divisible by 7. It is divisible by 8. So if we ask the members of army band to stand in 8 columns, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So how many rows? 1, 8 fours are 32. 8 fours are 32. So if they stand in 8 columns, we need 4 rows. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So 8 fours are 32. These are the members of army band. They are standing in 8 columns. They need to stand in 4 rows. Then remaining 616. 616. So 616 you divide by 8. 8 7 are 56. So what is remaining? 5 0 8 8 7 are 56. 0 0 divisible. So remaining members of army contingent, they will stand in how many rows? 77 rows. 1 2 3 4 5 6 7 8 numbers. Then 1 2 3 4 5 6 7 8. Like this, how many? Here 77 rows. Here 4 columns. These are the members of army band. These are the members of army contingent. They will stand in this way. But I am making you to understand the question. You might have understood. The question is to find highest common factor, HCF of these two numbers. HCF of these two numbers is the answer. HCF of these two numbers is the answer. So now we shall write answer. These are all dots and these all discussions not necessary to write in the exam. Directly we have to write the question. What is the question? Once again I will read the question. An army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? Maximum number of columns. Maximum number of columns in which they can march is nothing but it is HCF of 616 and 32. So you can use any method to find HCF, but since this question is on Euclid's division lemma, we shall use Euclid's division algorithm to find this. I'll use short method to find the HCF. So short method is just take bigger number 616, divide this by 32. So 32 2s are 64 is bigger. So you have to check by 32 into how much. So 32 into how much? It goes approximately 32 into, if you take it, say 32 tens are 320, 32 tens are, so by 18, 18 twos are 36, 54, 57, so check by 19, so 19 means, so 2, 8, 0, 608, 19s are, 32 19s are will come, 32 19s are 608, 32 19s are 608, so 16 minus 8 is 8, this is 0, this is also 0, since remainder is not 0, divide the divisor by the remainder, so I am using shortcut, so 32 you write here, 8 fours are 32, so 0 0, remainder is 0, so our answer is this, 8 is our answer. So HCF of two numbers is 8, because this is the divisor which gives remainder 0, so this is equal to 8, so maximum number of columns is 8, this much is the answer, remaining was the explanation. I'll go to next question.